Um, Number 24, stating like a scoop of ice cream is a sphere with a diameter of 10.
One second. Let me draw this out here, and while staying in the scope. First, let me write what question it is. So what's the question number?
Number 24.
On what? On what?
On the review.
Okay. So number 24, review. What does it say?
A scoop of ice cream is a sphere with a diameter of 10 centimeters.
Okay.
Suppose it is placed in a cone with the same diameter. What should the height of the cone be so that the same amount of soft ice cream would fill the cone exactly?
So what was the diameter? 10. So centimeters?
Centimeters.
So this is going to be 5 centimeters of radius. So what was the question asking?
What should the height of the cone be so that the same amount of soft ice cream would fill the cone exactly?
So we have a situation here. We have a cone, and it's housing a sphere. So let me get this straight. All we know that is the sphere has radius 5 centimeters, and it's asking what is the height. So that what happens?
So that the same amount of soft ice cream would fill the cone exactly.
Soft ice cream would fill the cone exactly. Okay, so I don't know how that solution approaches it. I know what I think that means. I think that means that the cone just perfectly stops at the outermost great circle on the sphere. Meaning, like what I've drawn. The cone is the same radius of a cone as the ice cream's sphere.
The cone part is the same as the ice cream.
Yes, okay. So that's what we have here. So what we want to do is we want to calculate the height. Notice that this distance from here to here is also 5 centimeters, right? Okay, for everybody watching from home, feel free to ask questions here in the chat. Okay. So we know what is h. So we know, let's call this whole thing capital H, which is the true height. Capital H is what we really want to know. That will be equivalent to h plus r 5 centimeters. Would it not?
Yeah. So
If I'm understanding the problem correctly, yes, ma'am.
what is that deviation? What is the little h?
Good question. The little h is the distance from the tip of the cone all the way to where it touches the first piece of ice cream.
And the big H is the tip of the cone to the sphere.
Yeah, all the way up to the center of the cone, where the cone ends. So here's a cone, right? Here's the radius of the cone. This whole distance would be capital H. From here all the way to here.
Little h is the
How
from the tip of the cone to the
ice cream?
little circle. The bottommost circle is ice
Okay. that's just kind of how I set it up. You can just proceed to calculate volumes, really. What is the volume of the sphere? We have everything we need to know. That is 4/3 pi r cubed. It's elegantly proved using infinite pyramids. So I get 4/3 pi times what cubed? 5 centimeters cubed. What's 5 cubed? 125. So 4 times 125 all over 3 pi centimeters cubed, whatever that is. You can multiply through and probably find a decimal, which is approximately 523.6, if I can trust this. You guys double check it for me. Is 5 cubed indeed 125? Yeah, it's 25 times 5. Yeah. And then multiply that times 4, divide by 3, and then multiply that times your pi. Is this what you're getting around? 523.6. Are you guys getting a different answer? It's okay if you are.
I am, because I don't know how to work this calculator.
We'll get to the bottom of it. Let me do it real quick, man. Is it correct? You got the same? Hope? Okay. All right, guys. Some people are getting it, some people aren't. At the end of the day, I'm a mathematician, not necessarily an engineer, even though I have done theoretical nuclear physics research for the United States government, which had some engineering, but it was mostly theoretical in nature. I digress. So it's not the number that's super important. Maybe you did a slip of the finger on a calculator. It's whether you knew to use this and use it appropriately. So we got the area, volume of a sphere. What is the volume of the cone? What area? Yes, very good. So this is 1/3 area of our circle, which is what? Times what? So what? I don't have my hearing aids in today, huh? Times the height. Oh, you're saying we don't know it, huh? Do we know the height? Shrugging the shoulders is an evolutionary response in order to protect the neck. It's a sign of submission, and we don't submit.
No, we do not.
Okay. So this ends up equaling 25 pi h over 3. So we don't know it. But, okay, the problem is kind of weird. The way I've drawn it is not really what's going on. The ice cream is going to melt into the cone, right? And perfectly fill the cone in. So what can we say about that then? What are the volumes? What is a statement we can make about the volumes? Yes! They're equivalent. So this is in some centimeters cubed. Don't forget your units. Yes, ma'am.
What is that 25 pi? Yeah.
Oh, this is the volume of a cone formula applied to the cone. Yeah, forget this height is equal to h centimeters stuff. I didn't understand what the problem was asking at first. I didn't know. What the problem is saying, the sphere melts into the cone and it evenly fills out the cone. So yes, the key here is to say V cone equal V sphere. Because you have a pure number on one side of the equation, and then you have a variable on the other side, and you can solve for that variable. So without further ado, let's algebraically solve for that variable. I get 25 pi h over 3 is equivalent to 523.6. So, okay, first I multiply both sides by 3. So I get 3 times 523.6 is equal to 25 h pi. Then I divide by 25 pi and I get h is equal to 3 times 523.6 divided by 25 pi. So what is that approximately? Is that what you're getting? It's approximately 20 what? 20 what? Centimeters? Yeah, it's a centimeters.
Did y'all divide by pi already?
You have to, yeah. You have to divide by pi.
But did you already?
Yes, we already divide by pi. If you want to get a pure number, you have to divide through by the pi. You can keep it in terms of pi, and I wouldn't count off. But if you're truly interested in what the measurement quantity is, you need to divide by the pi or multiply through the pi. Which is why knowing pi to more and more decimal places is important for not only theoretical, but for application calculations.
So if we, on the test,
Yes, ma'am.
multiply it with pi, you're not going to count as wrong?
No.
Okay.
They're both right.
Okay, just making sure.
It's like, the question is, Professor Niazi, be inside the room. I'm in the room here. I'm also in the room here. I'm just in a different part of the room. I will not count off, and I will be the one grading the test. I won't give that job to the grader. Question? Can you what? Oh. Yes, ma'am. Okay, let's do it on the board so everybody can hear and benefit from it. Yes, ma'am.
Are we gonna need actual calculators for the test?
It would be beneficial if you had calculators. If you don't, just leave your final answers like this, and I will give you full credit.
Could we use?
You don't need a calculator for that. Actually, that 523.6, you could have just left it like this.
Could we use Mathway though?
Could you use Mathway?
Because I mean,
I don't know if I'm comfortable with letting you guys use that. I'm not saying it's like, you kind of need to be able to do it on your own. I know Mathway is not just a calculator. Yeah, Mathway is a computer algebra system. So it can solve equations for you and do a lot of neat stuff that I don't want you guys to have at your disposal. I want you to do it the old-fashioned way. Yes, you can use calculators. I'd prefer if you didn't use your phone. See, what I'm saying is you don't have to use calculators to get the answer. You could have left your answer like here. So instead of having this 523 business, an equivalent thing to this is this: 3 times 4 times 1, 25 pi, all over 3, all over 25 pi. If your answer was that, I'd give you 100%. That's called doing calculations in exact form. So you don't need it. Okay, we'll see. On the test day, if I end up saying that no, actually maybe they need it and you don't have a calculator, we'll see. Right now, I'm gonna say no. Maybe on test day, I might change my mind. But I would bring a calculator if it makes you more comfortable, because that for sure will be allowed. Mathway is like, I'm leaning on 99% it's not allowed.
Does the math department have any calculators?
That's a good question. I believe they do.
'Cause
I don't know
have
how
a
many.
calculator, but I know like there's several that don't have them.
Yeah, this is my first semester teaching here, so I'm not sure about all the things that they have. I'll ask my colleagues about it. I'm sure they have spare calculators. Okay, so that problem with the pyramid surface area, Haley, Hannah, oh, got it the second try. All right, Hannah, I can remember your last name, Westrick. Yeah, I can remember your last name, but not the first name. Well, okay. I'm more of a face person than a name person. But now with these, I can't even be a face person. So, what was your problem? Yes.
The regular square pyramid, altitude is the same as the edges of the base.
Oh, that's very neat and convenient.
I already found that.
Okay, so edge of the base is 6, and so is the altitude. Okay. Now what?
I just got something different.
Again, that may have not been me. That may have been like Dr. Turner's solutions. But let's do the calculation together. Okay. Oh, also, if you guys haven't turned in any of the assignments that was supposed to be due, if you're late, I'll give you up to test day to turn it in. No penalties. But after the first test, if you still have stuff from like measurement 3, measurement 4, whatever, those will have to be docked. Probably giving you major deductions there. But I want to encourage people who want to keep working on stuff and get credit. So, yes, ma'am.
Does this count for whenever we return one time and another group?
Yeah. Yeah, exactly. That's fine. That was fine in the past, but I'm starting to think it's not good to do that.
Okay, so back then when it was allowed.
Then it's cool. Yeah. No, yeah. Last time I checked, I have not created a theory of quantum gravitation that would allow us to go backwards in time utilizing exotic matter to open up wormholes yet. So it would be impossible for you to do that. Yes, I do. Matter of fact, I work on the theory of quantum gravity that I'm developing every day. I don't know what number it is, but we're aspiring to find the surface area here. And we know the base is 6. We know the height is 6. So one of the faces is 1/2 base times height, which is 1/2 6 times 6. So how many faces are there? 1, 2, 3, 4. So then I'm going to multiply this whole thing times 4. 4 times 1/2, 6 times 6. But we're not done, right? There's that what remaining? The base, the what it's sitting on, right? So we have to add that to, how do we calculate the area of what the pyramid is sitting on? Yeah. What's the area for that? Yes, 6 times 6. So this ends up becoming 2 times 36 plus 36. That's 3 times 36. That's 902 maybe? 902. What am I saying? Yeah, you should be 102. And it might not even be 102. Somebody please double check me here. It's not a decimal. I fell out of a tree when I was a little kid, and I've never been good at arithmetic. 108. Never been good at arithmetic, even though one of my favorite research areas in mathematics is geometric number theory. You don't have to do arithmetic for it.
That's not the answer on the key.
Yeah.
Is that the answer you got? That's the right way to do it. Yes, ma'am. Yeah.
So it just took surface area of a square pyramid, and then it used that.
We never talked about that. I don't.
Yeah, that's just like we were confused on it.
Yeah.
and so
Ignore that. Ignore that. All that. Ignore that. Do it like this. Did you guys get that? On the key, it says like some square root of this and that business. Just ignore that and calculate it like this. Just calculate like this. It's very simple. The surface area of this pyramid is four triangular faces plus a square. I would give you 100% for this one. Okay? Any other questions? Yes, ma'am.
On the key, it has a bunch of definitions. Are we gonna have to know all of that?
I would say it wouldn't hurt to know those definitions. I mean, we talk about them all the time. We've been talking about pyramids, we've been talking about cones, we've been talking about prisms. So it would be very helpful to know those definitions. Yes, ma'am. If it asks you for it. Are you asking me what's going to be on the test? Yeah, no, I can't tell you that. Someone was emailing me saying, is this the test with the problems rearranged? And I was just like, I'm not going to disclose that. Yes, ma'am. I would say probably write it out. But unless you're like way off, like if you're describing a sphere as like a object that grows in a desert that has points on it, of course I'll be very lenient on that, you know. Unless you're describing a cactus for a sphere, I would like then maybe count off some points, but it's pretty straightforward. It's not a lot to memorize. Yes, ma'am. Yes. Sure. Yeah, you can write them all there and then record it on if you're asked for it.
Sorry, there's some people who are like.
I would say just front, not front and back.
Okay.
And here's why. I don't want you to like spend your whole time adding a bunch of stuff on this sheet. What will really help you out here is practicing the problems. Yes, ma'am. Yes, ma'am. Do you have a question? Oh, okay.
Sorry.
You're okay. I just want to make sure I'm answering everyone's question. For people at home, how would you like us to take our test? Shelby, I will email it to you, and I'll ask you to email it back to me within the time frame.
Okay.
Okay. You're good, Brecken. Hopefully you're feeling better. Keep drinking that water, keep eating that protein, keep getting them sleep Z's. Any other question? But any other questions?
I'm just really confused why the other person did it like completely off. Like why they made it so much.
Because that was like probably like maybe up to 10 to 15 years ago, and the course is slightly different. Maybe they talked about that in the course back then, but we're not talking about it now. Yes, ma'am.
So how many of these do you think are wrong?
I would hope that not many of them are quote unquote wrong, but what do you mean by that? On the homework or on the?
Yeah, so if we got an answer that matches the key and we were like, oh, it matches the key, it's good. Are you gonna take points off if it's actually wrong?
So there's no way a problem will 100% match the key because you won't be getting the same problem. But if you attempted the problem in a way in which the key suggested to you and that was wrong, you shouldn't be penalized for that. And so I'll make sure to give you your points back. Just bring it to my attention, okay?
No, I'm working at all of these, I checked.
But I did them all by myself.
So here's what I can do. I can redo the solutions for you guys, but there's very little time left, so.
Oh, yeah, no, you wouldn't, you don't have to do that today.
Right. Any other questions? No, over here. Questions here? Questions back here?
I got a question on something.
Yes, ma'am. Let us hear it so we can solve it as a group.
I don't remember what it was on.
Okay. We'll find it out and then let me know.
Okay, so it says to find the area of an equilateral triangle with the sides of length S. Does that mean all sides are the same?
Yes, ma'am. That's right.
How would you go about doing that?
The area of this? Okay, well, the area of this is, it's an equilateral triangle, so all the side lengths are the same. So the formula for an area of a triangle is equal to what? 1/2 base times height. So we know base is S, but we don't know height. But we can solve for height using the what? Yes, ma'am. The Pythagorean Theorem. So notice that you can construct this triangle. So you get S squared is equal to 1/2 S here. S squared is equal to 1/2 S quantity squared plus H squared. I said 1/2 S because the altitude would bisect this line segment S in half. Then, I mean, are you given, it's just, you're not given what the sides are. So we're just going to keep this in general. And so that you guys don't get confused, I'll put a line through it so it doesn't look as like a 5. That's right. So this is equal to, for 4 plus H squared is equal to my S squared. So we aspire to find H because we don't know H. So H will then equal, let's not do too many steps at once here.
Where does the divided by 4 come from?
Good question. Whenever you have 1/2,
Did you flip and multiply?
1 second, I'm getting to it. Whenever you have this right here, this is the same thing as S over 2 squared. And then you square the numerator and you square the denominator, and you get this. Everybody familiar with that? What prerequisite courses are you guys required to have to take this class?
High school geometry and algebra.
Just high school level? That's a sad thing. You know, I grew up in Oklahoma, and I went to the public schooling system here, and it's very, very, very low quality.
They really don't.
And they don't care. They don't teach you. They just say memorize these formulas, and that's why there's such this. That's why this class is probably a shock to you guys. You know, I'm running it like they would run a legitimate mathematics class where you guys are going to discover stuff and use your brain. You're not used to doing it because you don't have good teachers. But I take my job very seriously, and I want to be a really good teacher and encourage a lot of growth in every single one of you, because you guys are going to go on and become teachers yourselves. So the more I can influence you, the more I can influence your students. So it is a great honor to me to be able to do that. So I take my job really seriously. I want you guys to get as good at math as possible while you're under my wing. Okay? So we solve for H and we get this is the square root of S squared minus S squared over 4. But we can get a common denominator, right? Because it's adding fractions. So I can multiply top and bottom here by a fancy number 1. This is getting really, really cramped. So let me bring the calculation over here. So inside that radical, I have s squared minus s squared over 4. Notice that that's really s squared over 1. So I can say that this equals, if I multiply top and bottom by a fancy number 1. I call that a fancy number 1 because it establishes the common denominator, but it still retains equality because anything divided by itself is 1, and 1 times anything is itself. So you can say this equals that, and you can put a 4 here, a squared minus s squared, everything over 4. So over here you get 3s squared over 4. That's what's inside the radical. So here's radical rules. The square root of some x over y is the same thing as the square root of x over square root of y. This is true in general. Furthermore, the square root of x times y is equal to the square root of x times the square root of y. Now I wish you guys were in my college algebra class first before taking this class, because you would have had this stuff down pat. Okay? So now you will know why I say I could distribute the radical to the numerator and the denominator. Okay? So that means you get s root 3 all over 2 as your final answer for your height. So the question said, what is the area of this equilateral triangle? In terms of s, right? Correct. S root 3 over 2. This 2 and that 2, they don't cancel, actually. They multiply in the denominator. So this gives me s squared root 3 over 4.
Yes, not except it has a squared after it. Does it need to have a square?
Yes.
No, it just has the square root of 3 over 4, and then on the end it has s squared. So it's the same thing.
Yes, that is indeed the area of equilateral triangle of side length s, represented in s alone.
How did you get these numbers?
Where?
Okay, so I got you at the h equals 3s squared over 4 square rooted.
Uh-huh.
I got that, and then you lost me at the top.
So, okay. So remember that the square root distributes across multiplication. So that's a very good question. The square root of 3 times s squared is the same thing as root 3 root s squared, which is just s root 3. Because the square root of anything squared is just itself.
So where'd that go whenever you moved up to the top?
It went in the numerator right here. The root 3s is now in the numerator. And square root of 4 went in the denominator, which is 2.
Oh, okay, so then 1/2 s root 3 over 2.
Yes, ma'am. Does that make sense?
Why did the 4 go away?
Because it's the square root of 4 is 2.
Okay.
This is on the recording, so you can rewatch this over and over again and pause it. Make sure to record it in your notes too if you want. Yes, ma'am.
Can I go over number 6?
For sure.
It's a sector of a circle with radius 6.1 centimeters contains an angle of 135 degrees. Find the length of the arc.
Okay. My apologies. If you could say that one more time.
A sector of a circle with radius 6.1 centimeters contains an angle of 135 degrees. Find
Okay.
the length of the arc.
6.1 centimeters. Angle how much?
135.
135. Then what?
Find the length of the arc.
Oh, find the length of the arc. So, did we even talk about this? We never even talked about this.
No, we have.
We
We
have
did
for
a
a
short
short
time.
Oh, yeah, we did talk about this.
I mean,
I don't sleep a lot, guys. We did talk about it, didn't we? Or we talked about,
A long, long time ago. Nobody probably remembers.
well, okay. So the way I've drawn it, that's not even an accurate representation of 135 degrees. It would be more like something like this, right? Mm-hmm. Okay. So, yeah, we did. We talked about S is equal to R theta, didn't we?
No, we didn't do the theta.
Did we talk about how in 360 degrees there is 2 pi r? We did talk about that? Okay. So this is true right here. So in 360 degrees, there's 2 pi r arc length. So had we gone over the whole thing, I could tell you how long this squiggly string would be. It would be if I replaced this with 6.1. But we didn't. We didn't go through the whole thing. We only went through part of it. So what is this part of it?
Would you have to set up a ratio?
Yeah, you would say, okay, if in 135 degrees, let's multiply that times this ratio, but flip it. Why do we flip it? Because we want to cancel what? The degrees, yes ma'am. We want to cancel out the degrees in the numerator and the denominator respectively. Now we will know how much arc length we traversed. So we just replace r with 6.1 centimeters. So it's 135 times 2 pi times 6.1 centimeters. Everything divided by 360. That should get you your answer. Say that again, please.
You're not multiplying the degrees by both the numerator and denominator.
Yes. Yes. Everything is technically divided by 1. Yes, ma'am.
So on the reducing, there's like a different way to do it. You have to do it this way.
It would be okay. Yes, ma'am. I'm most likely familiar with that way as well. Yeah, I haven't looked at
Yeah,
it.
we did the S equals R theta.
Oh, okay. Would you guys like to learn it that way as well? Okay, well, S equals R theta only works when theta is in radians. It doesn't work when theta is in degrees. So there's a technical issue there. And so actually, you could convert it into radians, but it would require more steps. So in 360 degrees, we have 2 pi radians. So we would have to convert 135 into radians. 135 degrees, I would have to convert this into radians by utilizing this. Cancel, cancel. So you get your answer in radians, and then you can plug it into that, which is exactly what we're doing as well. I think I framed it like this so that you guys wouldn't have to convert into radians. But we can. So this is how you do it. And what is this value here? 135 times 2 pi divided by 360. 135 times 2 times pi divided by 360. That's 2.35 radians. So plugging it into S equals R theta, S is equal to R 6.1 times this 2.35, which should approximately give you the same answer. Yes, ma'am.
So once we write down,
Say that again.
for the, once we get the answer, is there like certain like measurements we need to put? Like,
Yes. So it's asking you for an arc length. So what is your final answer have in units? Centimeters. Because it's in your calculation. We canceled out degrees and we have only centimeters left. So it's in your mathematics that it's in centimeters. That's why math is cool. Like, it's just engineered to have the appropriate units. Yes, ma'am.
If we go through and work out these problems that are on the review, since there have been some that are different on the key, tomorrow when we come to like study session, will you look over the pictures?
Absolutely. Yes. Yeah. This is not the only course that I teach. So I overlook these things. You guys brought it to my attention, but I overlook them. So I do care about you guys. I'm just spread so thin. I do care about each and every one of you. Okay? But I'm just spread really thin. So if you see something and bring it to my attention, I will always be on your side. I'll give you points back, and I'll make sure if there's questions on the test that have stuff that we didn't talk about, I'll just give everybody points for it. You get 100 on it because you're not to blame for not having that. Okay? Sound good? I'm always on the lenient side. Because I'm so hard on you, once it comes down to actual performance, I'm just like, okay, they've had enough. Let them have a little easy session here. No, you haven't, because this is just the first test. There's a lot more tests left.
What I have.
It says it on the syllabus. Yes, your tests are worth 50% of your grade. It says it on the syllabus. I can look. Yes, ma'am.
4. I have 2 tests.
Yes. See you later.
This
Yes, ma'am.
says 2 tests.
Huh? Yes. What does it say? Okay, everybody, you're gonna have to be quiet because I'm trying to listen to Yahira talk. What's she saying? Okay. A rhombus. A rhombus. Is it on the exam key? I actually forgot what a rhombus looks like. What'd she say? It's number 7? Oh, okay. It's just a 3D. Here we go. So what is the side length? Okay. This one is 8. What about the slant? 6. And we're supposed to find the area of the parallelogram?
Well, on the key,
Mm-hmm.
it says the other side is 8 as well, and then the diagonals in the rhombus.
Okay, so this is a diagonals on the rhombus.
Like inside it.
Oh, here?
Yes.
Aha!
That's what it shows on the.
Okay. So now we're supposed to find the area? Okay. That's not that bad. So let's take a look here. We can break up this parallelogram into 2 triangles, can we not? Here's T1, here's T2. I've drawn T1 right here. I've drawn T2 right here. Okay. Notice that if this is 8, this is also 8. If this is 8, this is also 8. And this is 6. So, and this is 8. So what is the area of a triangle? Because if we can find the area of these 2 and add them to each other, then we know the area of the parallelogram. Right. 1/2 base times height. So we know the base here, we know the base here, but what's the height? It's 3. How do you know that? Cut it in half. Cut it in half. So if we cut it in half, what happens? These are right triangles. To solve for this height? Very good. So upside down wise, this becomes a 4. This is our unknown height, and this is the 8. Pythagorean theorem says 8 squared is equal to h squared plus 4 squared. Solving for h squared, I get that this is equal to 8 squared minus 4 squared. Taking the square root, I get this is equal to h is equal to the square root of 8 squared minus 4 squared. This implies that h is equal to the square root of 64 minus 16. That's bring that down 48, I think. Probably wrong. Is it wrong?
It's
64.
48 inches squared.
It is 48. Wow, that's a miracle. Okay, so h is then equal to, this is 2 times 24. H is then equal to 2 times 12. So then this is equal to the square root of 2 squared times 3 times 2 squared. So this breaks down to 4 root 3 is equal to our h. The reason I say that is because when you distribute that square root, this is what we had here is this distributes to each of them. And the square root of 2 squared is a 2. And then 2 times 2 is 4. It is really hot up in here.
It's cold.
So we got h to be 4 square root of 3.
We got the height to be 4 square root of 3. Yes, ma'am.
But I kind of see what she was saying about how it would be 3.
Oh, you're saying,
Why is it not 3?
Because if you cut the 6 in half, that's gonna be 3.
oh, yeah, that's measuring diagonally though. It's not measuring vertically. The height needs to measure vertically.
Oh, because the 6 was, okay, yeah.
Wait a second.
I don't know what you're saying.
I need to look at,
Because like if you drew.
oh my gosh,
this
yeah.
one, yeah.
I have overcomplicated this problem. So this triangle looks kind of weird. The way once you chop it up and set it down, it's more like this. This is an A, and well, I don't know if that's, see, if this line is perfectly vertical, we could say that the height is 6, so the area of it is 1/2 6 times 8. But it's kind of slanted, so we can't really say that. You can measure something to be 6 sideways, and then measure it like this, and it's no longer 6. Does that make sense? Yes, ma'am.
All he did on the key was area equals 4 times the grouping of 1/2 times 3 times 8.
And you got 48 inches. What?
How would it be 48?
What are we looking for, the height? No, it's the area.
Yeah, that's what I said.
Yeah, so the person who made these solutions is assuming that the height is 3.
So should.
For how many more?
Yes, you can do the same. Yeah. It's just kind of like, you know, what they've made is not necessarily true in general, to be overly technical.
So what they did on the key is wrong.
Technically, it's not true always in general, but you can do that for your purposes. It's not always true in general that the height of that triangle will be a 3, because that slanted line might be, whenever you set it down on the base 8, it may not accurately measure the vertical altitude. If it falls short or overestimates, the overall area is incorrect. And I'm being really overly technical, but I'm a mathematician. You can't blame me. This is like my job, to be overly technical with these things. feel free to do your problems like that. If they ask you for something like that, do it like that. Any other questions?
I'll ask more tomorrow.
Okay. Room 200 at 8:30. I feel that. I wake up at 6 in the morning every day. Yes, ma'am. What'd you say? Oh, I can, yes. Yes, absolutely, I can zoom it. Yeah. It has a document. You get extra credit? Yeah. Sure, why not? No, I'm not going to give extra credit for showing up. What I meant was you're going to get extra credit because you'll be able to learn more, which will increase your performance. You don't let me finish. I may include a bonus problem on the test, so then there's your extra credit there. I can include many bonus problems, maybe like 3 or 4. I'll give a lot of partial credit. Yeah, that's not testing you though. I want to challenge you guys. Don't you guys play soccer? So which coaches made you better? The ones that were like, oh yeah, just play around and practice, or run, drill, shoot, dribble. It's the ones who are tough on you that made you grow the most as a player. Any question? Is there any way to Zoom it during the math session? Yes, I will Zoom the math session and upload it. Sound good, guys? Everybody has left physical class now, so if you guys have any questions right now, I'm like available. You can either type it in or undo your mute. I guess I can undo your mute for you, or you can undo your mute for yourself or something like that. If you have any questions, let me know.
I'm all good. I'll watch the Zoom tomorrow for the math.
All right. Nice.
And then you said for everyone at home, you're just going to email us the test on Thursday, and then we just email it back to you?
Yes, ma'am.
Okay.
Does that sound fair?
Yes, thank you.
Mm-hmm. Yeah. I'll expect you to email it, before the deadline is passed. But, if it's a few minutes here and there, I'm not going to trip, especially since you guys aren't feeling well.
Okay.
Mm-hmm.
Thank you.
No problem. Just don't abuse it. Not 3 hours later.
Will do.
Uh-huh. Do you have any questions?
Nope. I'm good.
Okay. Brecken, Nikki, sorry. See you guys later.